All right, guys. So to solve this equation, the first thing we're going to do is we're going to fill out our ice chart. So I'm going to place all the things that we need right on top so that we know what they are. First thing we're going to write down is going to be this HCO3 minus, then the H plus, and then the CO3. Note that we checked all the states and all the states are aqueous, so everything goes into the problem. Next, we're going to go and we're going to see if 0.16 moles of HCO3, so we know that we have this 0.16, right? But I'm going to put it to the side, moles, because I want to first divide it by 1 liter, which allows me to automatically change this to 0.16 molar. It's placed into a 1 liter solution. What is the equilibrium concentration of HCO3? Remember, in the very beginning, we never have any product. So we put zero for the products. And then what's going to happen is we're going to gain some products. And when we do this, I want you to notice that I'm looking at the coefficients. All the coefficients are 1. And since all the coefficients are 1, I'm allowed to go minus x because we're losing reactants and we're gaining products, so it's plus x, which will end up giving us x, and then 0.16 minus x. Okay, now we plug in the K. So when we do K, we go K is equal to the concentration of H plus, the product, CO3 2 minus, a product, divided by the reactant, which is HCO3 minus. Now, once we do that, we're going to place all the numbers inside. So K is going to be equal to X times X divided by 0.16 minus x. Okay? We know K is equal to 5.6 times 10 to the negative 11. And now, all we have to do is solve the problem. However, when solving this problem, you'll notice that we have this minus x right here. And so a lot of times, especially in the AP problems, you should expect that if you see a minus x, minus 2x, plus x, that these are going to disappear because they cause us to have to do a quadratic. And since it causes us to do a quadratic, most likely they're going to design k's to be so small that your answer for this will be small. So we assume x is smaller than 0.16. That's really a more accurate way of doing it. For me, you'll notice that a lot of times I just say it's small, and so that's what happens. What that does is it will eliminate our x. So this will disappear, okay? So then we don't have to worry about it. So what that'll do is it'll lead us to this new problem, which is 5.16 or 5.6 times 10 to the negative 11 is equal to x squared over 0.16. Now, how do we solve? We multiply by 0.16 on both sides, 0.16. That will multiply this by 0.16, okay? And then we'll square root that, okay? And then we'll get our answer. So x is going to be equal to the square root of 0.16 times 5.6 times 10 to the negative 11th. So x, we're going to go up here, is equal to, I'm going to plug that into our calculator right now, square root and then 0.16 times 5.6 to the 11th, and close our parentheses, and we end up getting 2.99, but looking at significant figures, notice that the significant figures is only 2, so the answer will be 3.0 times 10 to the negative 6, and that is going to be our x. Remember, you can't just leave that. So let's go a little bit further. The concentration of CO3 2 minus is equal to 3.0 times 10 to the negative 6. This will be your answer.